In this session, I'm going to show you now how to lay out equipment racks. Equipment racks contain the IT hardware that generates heat in a data center, and they can be modeled several different ways. So up here in the upper left-hand corner, I use my left mouse button and I drag and drop a rack into the room. The way CoolSim works is that racks are in groups. The group simply means that they're all the same size. The default size is 5. You can change this to anything you like. So if you'd like to have fewer racks in your row, you can make it 3. I tend not to use library items for my racks. I simply set the height. Racks are generally all the same except for the height and width and depth, so I generally set them up uniquely. You can set them either using standard measurements, or you can also use U's on the height. You notice this one is a 48U rack. Also, airflow direction is indicated with these arrows, and you can see that one of the arrows is a different color than the others in the row. You see this one's a little lighter. That's indicating rack 0, because sometimes you'll rotate these around and have them pointing the other way, and you'll think rack 0's here. It's not. It's over there. There's also reverse flow direction. So you can use that to keep the rack numbering sequence correct and still have the airflow in the right direction. So either one of those two will work, however you want to do it. There are also different types of racks. We have 3 types. We have a front to rear, which is the most common. We also have a front to top. If you select that, you'll see an arrow now coming out the top as well. We also have a front to rear to top, which is rare. It looks the same from image point of view. We still make it go to the back and to the top, but it's actually distributing air both out the rear and out the top. That one is not used very often. It's usually one of these two, front to rear or front to top. If it is front to top, you can also put a chimney on it. Under geometry, if you scroll down, you'll notice there's a vertical exhaust duct that can be used to put a chimney on it. If you model it this way, it assumes all the air goes in the front, it comes out that chimney. It's a perfect system. Keep that in mind. In fact, these racks are modeled generally as perfect systems. They assume that all the air going in the front goes out the back, and that's not always true, but it's a good first pass assumption to make. It does assume that whoever's put these racks together has been careful about making sure there's no leakage. These also sit directly on the floor. They're at y equals 0. So they're sitting on the floor perfectly. There's an inlet on the front, an outlet on the back. Those inlets and outlets are the size of the rack. They're exactly the size of the geometry. And so they are assumed to be perfect in their representation. We can change that, but it's not a bad first pass assumption. So now let's take a look at specifications. There are a couple ways to do it. One is all the racks have the same heat load. So we signify our racks by heat load, and it's in kilowatts. And it assumes that this number, 4 kilowatts, is uniformly distributed across the entire height of that rack. That's the assumption we're using here, and that all the racks in the row are the same load, and that the temperature rise across them is, in this case, 20 degrees. These things can be changed. You can make this, of course, 30 degrees. You can change the heat load per rack to whatever you want. But it does, in this case, assume they're all the same. You notice the flow rate is changing as I change the delta T. Smaller delta T's will give you higher flow rates. The relationship is just about 154. You see there, CFM per kW. That's what satisfies the convective heat transfer equation for 20-degree delta at sea level. If you change your density, change your elevation, these numbers will change a little bit, but at sea level, that's how it behaves. So let's put in 3 here. 3 is a normal number, or 4, 5, something like that. Let's also now not assume they are all the same. If I want the different wattage per each of these racks, instead of building individual racks and then putting them close to one another and dealing with that, I can do them all here using this individual rack selection tool. The individual rack selection tool brings up something that looks very much like an Excel spreadsheet. We did that intentionally. And now it's quite easy to go in and say, well, the first one's really 4, the second rack is really 2, and the third rack, just like Excel. You can just go over and edit these cells just as if they were a standard Excel spreadsheet. Furthermore, these cells here represent the slots in the front of the rack. You notice we have 48. You'll also notice that it's numbered from top to bottom. Most racks are numbered from bottom to top. Keep that in mind. We did it this way just so we could vary the height of the racks and not have this interface change very much. So it was a constraint building the user interface that kept it this way. These are inverted. It hasn't been too much of a trouble for people, but keep it in mind. So let's say here in rack 0 that 4 kW is fine, but it's really not distributed evenly across the front of the rack. It's really right here. And see, I'm pulling down, I got my left mouse down, I'm pulling down 6 U's. There's a 6U server sitting right there, and I right mouse it. With my right mouse I can define a server, a blank, or a gap. A gap is a hole. So you can put holes in the racks to model racks that are not blanked properly or not sealed properly. But here I'm going to put a server in. Another small dialog pops up on my other screen. I'm going to call this an IBM, and I'm going to say the heat load here is 4 kW. So now I have changed the density. The density's higher right there. I've got an IBM sitting there, and it's got the 4 kilowatts. So these numbers override anything up at the top. You notice it's now gray up there. Means that my load is right there. I can also put gaps in the same way. Here's a gap sitting right down here. There's a hole right there. I get a small dialog here, and I say OK. And so now when I jump out of this thing and say OK and go back, I'm going to have a rack with a hole in it. You see the hole right there, front to back, and I've got a server sitting there as well. So you can do it either way. You can do average watts per rack, or you can get specific about what's in the rack and put blanks in it. Even to the point, if you want to, I've seen people take this system and they want to hollow out a lot of the rack row, make it so that it's looks like it's doesn't have much in it and it's not blanked. You can do that here by just going to individual rack. One of the things you will want to remember is that it does require at least a watt of power. You cannot run these at 0. The solver rejects it. So you're going to want to put a watt in it, but you can blank out most of it and put your watt of power maybe up here. So I'm going to put in a server. I'm going to put it in at 1 watt. You notice it defaults to 1 watt. But I'm going to hollow out the rest of it using just my left mouse here, and I'm going to make a big hole, big gap right there. And so when I finish that, it's going to have a server in it, but you see most of that rack row is hollowed out where I put the big hole. And you can make successive racks like this this way. So that's a quick overview of how racks work. You lay them out. Now we have some alignment tools as well. You're going to want to align your racks. Aligning racks is easiest to do in the top view. So I'm going to take this one and I'm just going to drag it up close to this one. Now I want these to be close. I don't want a gap between them, and I want the edges to be aligned as best I can. So this is not good, this gap. And the way to fix that is with a small tool we have where we allow you to align the fronts and close the gaps on anything, but we're going to do it right here with racks. So with my control key and my left mouse, I'm going to click the left one, and then I'm also going to click the right one, and then I'm going to put my cursor over the one I want to hold constant. One of them has to be still while the other one moves. So I'm going to put my cursor over the one I want to hold still. I'm going to use my right mouse button, and I'm going to say, first, let's align these so that the fronts or the backs are lined up. That's important for meshing, to get those lined up. I'm going to align it to, in this case, Z. Remember, Z is up and down. Minimum is the one closest to the top because my origin is in the upper left-hand corner, if you remember. If you forget, there's a little indicator down here in the lower left that tells you where the axes are. I'm going to align them to Z min, and that lines the racks up. Then I'll do it again, Control key, Select that one as well, put my cursor over the one I hold constant, and I'm going to close gaps in the X direction. And it pulls that rack row over to the right in. So now my racks are nice and tight, and I've got different kinds of structures in those racks. Okay? Quick overview on racks. That's how racks work. In the next session, we'll go ahead and put a solve. We'll solve it. I'll put some floor tiles in place. We'll solve it, and we'll start to look at some results. Thank you.